Hello guys, welcome back to my channel. So if you haven't subscribed my channel, please go and click the subscribe button so you can get more videos about COMSOL simulation. So in today's video, I'm going to show you that how you can simulate airflow over a person who is walking. So in COMSOL, I made this simulation in 2D. So in the first step, you need to select the 2D component from the add component. I already solved the problem, so I selected the 2D component and then I made the geometry of the person in SolidWorks and imported into COMSOL. So if you don't know how to import SolidWorks geometry into COMSOL, I already made a video. You can check the link in the description. So I made the geometry in DXF format, then I imported into COMSOL. You can see here if I click import, and then you can see here the person has been imported into COMSOL. The next step, we have to define the air domain. So I have selected 300 by 120 air domain. When I select build selected, you can see here the air domain has been built around this person. So in order to simulate airflow over this person, we have to subtract this person from the air domain. So for that, I selected the difference function. You can go to geometry and select the difference function from here, from boolean and partition, and you can select the difference function here. So I selected the difference function and I selected the object to add. So in this case, I'm adding air domain, and object to subtract, I added this person. And when I click build selected, you can see here the person has been subtracted from the domain. So finally, I will go and click the geometry and click build all. So now our geometry is ready for the simulation. So the next step, we have to define the air. So simply right click on this material and go to add material library and just select the air domain. So I have selected the air domain. You can see here this whole domain is air. In the next step, I have selected turbulent flow modeling, and I'll show you that there are different models. So we have used K omega model. So for the physics, you just go to physics tab and then click on add physics and select the single phase flow and then turbulence flow. In the turbulent flow, you can see here if I click here, you can see we are using our RANS model, and in this RANS model we have different models here. So in this case we are working with K omega model. You can also solve the same problem with K epsilon model. In the next step, we will go to the fluid properties, and we already defined the material as air, and here we are giving the properties of density and dynamic viscosity from the material. So in the next step, for the initial values, these are the parameters related to the turbulent kinetic energy and specific precipitation rate. So the next step is to apply the no slip boundary condition. So you can see here, so these boundaries are no slip boundaries. The next step, we need to define inlet. So you can see here, this one I selected an inlet. So in case of normal air, the normal air speed or breeze is 8.5 meter per second. So I have given 8.5 meter per second at the inlet, and you need to select specific turbulence length scale and intensity, and turbulence intensity you need to keep it medium, and in turbulence length scale you need to keep it geometry base. And at the outlet, you have to select this outlet zero pressure condition. So for the mesh, I have generated a physics controlled mesh, finer mesh. You can see here if I click build all, so you can see here it's a very fine mesh around the person and it's coarse mesh in the air domain. So if I go and zoom it, you can see here it's a very fine mesh around the person. So you can clearly see here the mesh quality. Okay, so the final step is to select the study, and we are going to solve the problem for stationary study, and then click on compute. So we have computed this problem for stationary study, and you can see here the convergence plot that has been solved for this problem. So finally we have results. You can come and click on this velocity function. So you can see here how air is moving around the person, and this is basically the surface. You can disable this one and see the surface plot. and you can enable the streamlines again and see that streamlines around the person. And you can also change the color of the streamlines. And if you don't wish to see the surface, you can disable, right click on this and disable the surface, and you can see the streamlines of fluid. Also, you can plot the pressure profile. So in this case, I have plotted the pressure profile in the line format, and you can go to contour and you can select the field and then plot, and you will have a surface pressure profile here. So that's all about today's video. Thank you so much for watching.